So Carla, can you read our title to 7.1, hun? Perfect. Okay, it's the inverse. So let's talk about how do we find the inverse function in your own language. How do you find the inverse function back then? We do. We switch x and y, and then you guys remember back then we solve for y after we switch it? Yep, same thing. So here we go. Line number 1. This notation right here, student, is read how? Right. Well, f inverse. Okay. So f, and then you see the -1 power is f inverse. So f inverse of f of x equals x for all values of x in the domain of f. And f of f inverse of x equals x. Okay. For every single value of x in the domain of the inverse. These are the property of for the two functions to be inverses. So what this means is when we compose, and guys, these do not mean multiplication. These are composition. What does the word composition mean? What is the word composition? One function is being what? Plug into another, okay? So when we compose the regular function into the inverse, it has to equal x. And at the same time, when we compose the inverse into the regular, it has to go to x, okay? So that's one property. The domain of the regular function, f is the regular function. Guess what? It is the same exact as the range of the inverse and vice versa, okay? Why is that? Why is the domain of the regular the same as the range of the inverse? Because we're switching x and y's. You're right. The graph of f and the graph of f inverse, remember this is read f inverse, are symmetric with respect to the line y equals x. Y equals x, students, it's called the identity line. Now, the word identity in itself, whatever you plug in, you get yourself back out. But that's why y equals x is called the identity line. Number 4, if a function, let's call it some random function y equals f of x, if it has an inverse, okay? The equation of the inverse function, can you guys see that all we are doing is switching x and y? It's this. That's it. But right now, later we won't, but right now, would you agree that we solve for y? To solve for y, that's what we have, y equals, and then this notation right here is to say, okay, well, I want to use this to say that this is really the inverse of that. Does that make sense so far? It's just a notation. It's not 1 over. I want to clear that up. Okay. Again, it's not 1 over. It's just a notation, so we know, okay, if you see this, and these, they're just inverses of each other. Okay. All right. Complete this on your own and answer the question to the right. We're going to try to see if we can do it together. Graph y equals sine of x. Students, what is the period? 2 pi, good. So period. Okay. So I'm going to make 2 pi to the right and negative 2 pi to the left. Each period has how many quadrants? 4. So I'm going to go up 1, down 1, okay? Chantal, what is sine of 0, hun? Yep. Very good. Okay. If we went all the way to 2 pi, what's in the middle? The tick mark smack in the middle. Pi. What's one tick mark worth? That's right. So each tick mark is worth a pi over 2. All right, Colin, what is sine of pi over 2?
1.
Perfect. Make a dot. Rachel, what's sine of pi, hun? Perfect. Sarah, what's sine of 3 pi over 2? Perfect. And Mia, what's back at 2 pi, sine of 2 pi? 0. Perfect. And then would you guys all agree that it's just going to repeat on the left side? Yep, follow the pattern, make your dot. Round out the min and max, put arrows on the ends, okay? We are stopping at 2 periods does not mean that this function stops at 2 periods. All right, is sine function a one-to-one function, y'all? What is a one-to-one function? Anybody remember? Pass vertical line test to be a function. What else does it have to pass?
The horizontal line test.
Right, horizontal line test. So vertical means it's a function. Is this a function? Does it pass a vertical line test? Yeah, it's a function. It's not a one-to-one because if I were to put a horizontal line test on it, it intersects my horizontal line multiple times. So it's not, okay? Because our answer is no, we have to restrict its domain so it can be a what? One-to-one, okay? And the reason we want a function to be a one-to-one is so that way when we turn it sideways, when we make it into an inverse, it's a function, okay? So universally, you guys are all mathematicians, right? We come together like, okay, look at this graph for me. As mathematicians around the world, where would we cut off? So this sine function can be a one-to-one. Okay, Jean said, I'm going to cut off from negative pi over 2 to pi over 2. Is that okay? I'm going to take a different color. And so Jean went, okay, well, I'm going to cut off here and here. Is this right here one-to-one? Okay, anywhere else that we can cut off? Okay, so Jake said, I want to do it here. You said pi over 2 through where? Okay, is that a one-to-one? Sure, there are so many, right, guys? But universally, we all have to agree. True or false? Yeah, so guess what we agree on?
Any interval from pi over 2?
Universally, we agree on negative pi over 2 all the way to pi over 2 because we like 0, right? 0 is easy to calculate. So whenever we can have a 0 in our restriction, we would. So universally, students, we have all agreed to be inclusive. Negative pi over 2 all the way to pi over 2 inclusive. Okay. Well, let me ask you this. What quadrant, students, is that if we put it back in the unit circle? What quadrant? Okay, where is negative pi over 2? Where's negative pi over 2? Negative means we go what direction? Downward, right? Is this a negative pi over 2 here, students? Okay, well, what quadrant is that? 4. And where is pi over 2? 1. Okay, so students, it is in the unit circle, we are cutting off between quads 1 only and quad 4. Okay, 1 and 4. Okay, so formal definition of inverse. Inverse of sine, okay, aka sometimes you'll hear me say sine inverse. And again, they give you y equals sine of x. What do we do to find the inverse? If the equation is y equals sine of x, we would x equals sine of y. Okay. And again, we right now don't like x equals, so we go in and solve for y. And you guys already know basic trig. To solve for y, we go in and do what? We compose sine inverse, right, guys? So do you guys remember this sine inverse notation? Okay. So y equals sine inverse of x, but because we want to use this f inverse notation right here, so this will tell, oh, okay, that's an inverse function right away. So that's what we're using for the inverse notation. Okay, the domain of sine inverse, the range of sine inverse. Well, the domain of sine inverse, students, is really the what of what? Domain of sine inverse is the what of what? The range of the regular. True or false? And then the range of sine inverse is the domain. All right. So we're going to do the domain of sine inverse first. What is it? And where did it come from? What is the domain of sine inverse? Lucas? And where did you get that? Yeah. Okay. Remember, if you even look at the original graph, can you guys see the range of the regular is from -1 to 1 only? So that's why the domain of the inverse is inclusive from -1 to 1. Now, the range of an inverse, can it be all reals? Can it be all reals? No, right? Because if it's all real, then it's not going to be a function. So, what do you think? Where did we cut off? What was the restricted domain earlier? From -π/2 all the way to π/2. So that is the range of the inverse. Okay. Now, sine inverse, students, could only be in 2 quads. What quadrant would sine inverse be in? We just wrote it above. What is it? 1 and 4. Now, students, sine in quad 1, what kind of answer would you get? All what? Positive. Sine in quad 4, what kind of answer would you get? All negative. That's why we only use one of each, so as not to confuse. So we don't ever have to worry about, oh, well, what quadrant? Well, there's only one quadrant for sine inverse that's negative and one quadrant for it being positive. Does that make sense? All right. Now we are going to graph out the inverse function. And again, remember, this yellow piece here is what we're graphing. Okay. So sine is when inverse is when we switch x and y for x. So remember, the original went from -π/2 to π/2. So now the y value goes from -π/2 to π/2. Okay. Pi, it's about what, y'all? What's pi? Yeah, 3.143-ish, if you really have to think about it. Would you agree that's about 1.5? True or false? Yeah, so if we had to make a 1 tick mark, 1 is how far about, it doesn't have to be exact, 1/3, 2/3. How far should we make it from pi divided by 2? 1, because we need to make a tick mark for 1. How far should we make it when we have π/3 already on there? I mean π/2 already on there. Half, 1/3, 2/3, 1/4, 2/3, right? Because isn't it pi divided by 2 is about 1.5? So so make sure, okay, well, 2/3 here, so we can make a 1 here and a -1 here, just so we have an idea of where to plot. Okay. Remember, we are only plotting, okay, the restricted piece. This order pair right here, students, is what? Originally, what was that order pair? First order pair, what was that? -π/2, comma, -1. So when we go plot it, how do we plot it? -1, go down to negative pi over 2. So negative 1, negative pi over 2. All right, next dot in the middle. It's what? 0, 0. When we flip it, we'll switch it. What is it still? 0, 0. Last dot up here. What is that order pair? Pi over 2. Oh, the original. Yep, I hear some of you. The original is pi over 2 comma 1. So we go over here and do 1 comma pi over 2. Yep. No, we don't go any further with its inverse. Now, can you guys see the original? What axis was it hugging? It's hugging the x-axis. So the inverse students should be hugging the y. Okay. So that is the inverse. So if you can sketch your sine, you can sketch your sine inverse. So students, this is F inverse equals sine inverse of x. Okay, in your team, I'm going to set 2 minutes for you guys to graph out y equals cosine of x. I want you guys to do 2 pi on the right and 2 pi on the left, okay? So negative 2 pi on the left. So 2 minutes. All right. So, all right, 2 minutes, go. Everyone, sketch out cosine of x for me, please. Do a period on the right, do a period on the left. Once you're done, please compare your graph with your friends. And then answer, is cosine a 1-to-1? And then do you guys remember the restriction from algebra 2 trig? Yeah, on the inverse function of sine, y'all, do not put arrows, okay? Because remember, it can only be from negative pi over 2 to pi over 2 and stop. Like it doesn't go on forever. I think a lot of you do have the right graph for cosine. Alexia, what would cosine of 0 be? 1, very good. Okay. And then Cami, cosine of pi over 2? 0, perfect. Lucas, cosine of pi?
-1.
Beautiful. Matt, cosine of 3 pi over 2?
0.
Perfect. Dean D, cosine of 2 pi?
1.
And then repeat the pattern, y'all, on the left side. Now this one, we do have arrows on the ends. Inverses, we don't, because inverses, we stop. If you happen to miss your dots, like I sometimes do, make it really fat. All right. Question, is this a 1-to-1? No, because you said no, buddy. We have to make it so it can be a 1-to-1 function, okay? Christian, do you remember from Algebra 2 trick where we cut it off?
No, but my guess is from 0 to pi.
Okay, 0. Christian guesses from 0 to pi. Will, what is your guess, bud?
0 to pi.
Okay, we have another check. Katie, what is your guess, hon?
0 to pi.
Okay, do you guys agree? How come, guys? How come I don't want to do it from negative pi over 2 to pi over 2?
It's not 1 to 1.
It's not. Can you guys see it does not pass my horizontal line test? So you guys are right. We're going to cut it from 0 to pi. So the restriction would be, students, inclusive 0 to pi. Let's talk about the quadrants. Where is 0? And where's pi? So what quadrants is this restricted to? 1 and 2, because this is 0, this is pi, and it's positive, so I go counterclockwise. Can you guys see it? So the quadrants here, students, is 1 and 2, and that will be the same as its inverse by definition. So here you go. Inverse of cosine, aka, students, you will sometimes hear me say cosine inverse. And all we do is what? What is the equation? Yep, x equals cos y. But we normally do solve for y, so we go in and write, okay, well, y equals cosine inverse of x. And we talked about using the notation f inverse of x. So that way we know, oh, okay, you know what? This is straight up an inverse function, okay? And we are going to fill out the domain and the range and the quadrants. Okay. Lindsay, what is the domain of cosine inverse?
The domain would be 1 and negative 1.
Negative 1 to 1. Perfect. Smaller number, comma, big number. Good job. Now the range, Cooper, what would be the range of cosine inverse, hon?
It would be 0, pi, pi,
0, comma,
pi.
pi. Okay. 0, comma, pi. Close on both ends. Now we talk about the quadrants. So when we are, Chloe, when we work with cosine inverse, Chloe, what are the only 2 quadrants we can use?
1 and 2.
1 and 2. Now students, in quad 1, all cosine answer would be what? Positive or negative? Positive. In quad 2, what happened to all cosine answers? Negative. Okay. All right, similarly, we are going to sketch out the inverse only here. So remember, we were restricted from 0 to pi, okay? And 1, where would the 1 tick mark be placed? A half, a quarter, a third, 2/3? Where would this be now? Oh yeah, 1/3-ish. You guys agree? Because pi is about 3.14. So I'm going to go up, make a pi. I don't know how much I need. I'm going to go negative pi, negative 1, and then down here, negative pi. Okay. So we go and use the original to help us out a little bit. The first original dot, student, how do we label that? What is that dot? On the top, what is that dot? Original. 0, comma 1. So when we go and plot the inverse, we plot what? 1, comma 0. Saying right there. And then the next dot is right here. How do we label that, y'all? Pi over 2, comma 0. So when we go and plot our inverse, we do what? 0 up pi over 2. Would you guys agree that pi over 2 right smack center? Okay. So that's going to be our 0, comma, pi over 2. And then the last original dot is here. What do we label this? Pi, comma, negative 1. So when we go plot our inverse, we would plot how? Negative 1 up pi, okay? Now look at the original curvature of cosine. What was it trying to hug? Which axis? The x. Okay, so now you must hug the y. So you need to, sometimes I find myself, it's easier for me to turn my paper. So if you need to, you can do that. No arrows at all, okay? So now check it out. Let me move it up really quickly to verify the domain and range, okay? Students, is your domain, look at this, is your domain from negative 1 to 1 on the inverse? Is your range starting from 0 and stop at pi? Yeah, they have to match, okay? All right, how much do we remember about tangent? A lot less?
Yeah.
Now, what is the period for tangent, y'all? I heard it. Pi, yeah. So, oh, shoot. Okay, so we only need to go a pi on the right and a pi on the left, okay? So period is pi. Now, if you don't remember much about tangent, then just make a chart. We know the period is 0 to pi. What are the remaining values in the middle? Pi over 4, perfect. What else? Pi over 2, and one more? Perfect. Okay. Remember, each period has 4 take marks. Go up 1, down 1. Okay, Jubilee, what is tangent at 0? Undefined, you guys agree? Tangent is what divided by what? Sine divided by cosine, y divided by x. Now I want you to imagine at 0 radians, which is here. What is x? What's x? 1. What's y? 0. So what is it when we say sine divided by cosine? What would you get? What's sine? 0. What's cosine? 1. So what's 0 divided by 1? 0, right? Undefined only if the denominator is 0. Okay. What's sine of pi over 4? We should love pi over 4. 1, yes. Okay. So Nick, what is, I'm sorry, not sine, tangent. Nick, what is tangent of pi over 2, hun? How do you know? Where's pi over 2, by the way, Nick? Look at, here's my unit circle. Where's pi over 2?
It's 90 degrees.
90 degrees, good. What's the order pair for that, bud?
0, 1.
0, 1. And tangent is what divided by what?
Y, right?
Good. So is it undefined?
Yes.
Yes, good job. Dean K, what is tangent of 3 pi over 4?
Negative 1.
Good. And Jake, what is tangent at pi?
0.
Thank you. Guys, make sure we get really good at these 5 order pairs, okay? All right, let's graph. I'm going to start with 0, 0. Pi over 4, go up 1. At pi over 2, what do we do with undefined? Asymptotes, okay? And then we are going to pick up over here, 3 pi over 4, negative 1. And then this. Guys, I got 2 dots on each side. Do I make a straight line on either side? No, continue, okay? And what I mean continue is this. As you can see, I'm starting here at 0. I have 0 on both. On the left side of that 0, I should make a dot where? Up or down? Down. Okay, so. And then left side of that is asymptote. True or false? True. And then keep on going. Okay. And back it up. And then back at 0. Okay. All right. Is this a one-to-one? Okay, I'm going to draw a horizontal line test. Is that a one-to-one? No, because it intersects more than once. Okay, so no. And this is because we said no. We have to make it so the function can be a one-to-one, right, guys? Who remembers where we cut it off? This is a review from last year, but we're negative pi over 2 to pi over 2, Lucas said. You guys agree? Yeah, inclusive or not inclusive? Not inclusive, because what's happening at negative pi over 2 and positive pi over 2? Yes, asymptote means it's not even there. So we go in, students, and write parentheses, negative pi over 2, comma, positive pi over 2. Now let's talk about the quads. What two quadrants is tangent inverse will be in if we're limiting it from negative pi over 2 all the way to positive pi over 2? It's still 1 and 4, right, guys? Remember, again, this is a negative pi over 2. Even though I cannot have a value at its negative pi over 2, and I cannot have a value at positive pi over 2, but the quads are still 1 and 4. Okay. So you already got the pattern here. Inverse tangent, aka tangent inverse. We switch x for y, so x equals tangent of y, but we have to solve for y. So we write y equals, which is really f of x equals what, y'all? Yep, y equals f of x. What do we write next? Based on the first two definitions, what do we write? Tangent inverse of x, right? Okay, let's write the domain. Domain for tangent inverse, the range for tangent inverse, and then we'll put it in quadrants. What quadrants? Okay. So check out the original range, okay, guys? Matt, what is the domain of tangent inverse?
All real numbers.
Yes, very good. All real numbers. Because the range of the regular was all real, okay? Lucas, what is the range of tangent inverse?
Negative pi over 2 to pi over 2.
Yes. Okay, non-inclusive. And we talked about the quadrants already. So Cami, what two quadrants is tangent inverse in? You're right, quad 1 and quad 4. Now students, in quad 1, tangent will be all what? Positive or negative? Positive. In quad 4, tangent will always be negative. All right, let's sketch out the inverse graph. Again, we're just going to go from negative pi over 2 to pi over 2. Okay. So that means the one tick mark is how far? A third, 2/3, a half? Where would we put it? Where would we put the one tick mark? Yeah, 2/3 of the way. Okay, guys? 1, 1, negative 1, negative 1, and a half is still normal, right, guys? Pi over 4. Okay, and then we're just gonna peek at the top where Lucas says we're gonna cut off, and then kind of. Okay, so Lucas said, okay, guys, only use. Whoa, I meant to use a highlighter. Okay, we're only using from here to here. Okay. Okay, we have asymptotes at where? We have asymptotes at negative pi over 2 to pi over 2. So we're going to do the same thing. We will have asymptotes at pi over 2 and negative pi over 2, except this time is not vertical. They are horizontal, okay? Okay, first dot here at the very bottom, what is that dot? Okay, I think you meant to say negative pi over 4, comma, negative 1. This dot right here, yes, no, maybe? Yeah. So when we do its inverse, we go where? Negative 1 down at negative pi over 4, right there. Negative 1, negative pi over 4. 0, 0 in the middle is still 0, 0, right guys? Yeah. And then our next dot here, what do we label that on the right side there? That was originally pi over 4, comma, 1. So now we're going to go to 1 and do pi over 4. Now look at the original. What was the curvature of the original? Hugging which axis? Y. So now we want to hug the X. I'm going to turn my paper sideways. And then remember, I want to get as close to the asymptotes as humanly possible without touching it. We do have arrows here. And then that's hugging the x-axis. I'm going to pinch it in so you guys can all see it. If for some reason you can't see, you let me know. We're going to go and see if we can answer examples 1 and 2, okay, before we call it a day. Find examples 1 and 2. Do we have a calculator? I'm going to teach you how to use a calculator. If you don't have one, please, you're welcome to borrow, okay? If you have one, go ahead and bust it out. You don't have one, stretch your legs. Alexa, can you read the instruction to example 1 for us, please? Okay, so we have to use a calculator. I just want to give you a heads up. Our answer has to be in radians. Okay, guys, so must be in radians. Okay, so to make sure our calculator is in radians, I want you guys to press the word mode. Find your calculator. Where is the word mode? Yes, next to second. Hit it. Okay, so in here, there's a couple of things. Can you see the word radians and degree? If radians is highlighted, meaning you calculate in radians. If degree is highlighted, then you calculate in degrees. So if somebody's messing around with you and change it, especially if you borrow mine, and change the degrees, and then on the test, you don't know how to change it back, you're going to be in deep trouble. So is the radians highlighted? Perfect. So now, if it's highlighted, go ahead, exit. Okay, now let's find example A, sine inverse of negative 0.13. Where is the sine inverse button, and how do we get it? Second sign, all right, everybody hit second sign, and enter in negative 0.13, close the parentheses, hit enter. You have a lot of decimals, right guys? But it said how are we rounding? 2. So what is the fine answer? Negative 0.13. Is it always the same answer? No, just this one. All right, let's do B. Everyone try out B for me. Practice with a calculator. So we need to get fast, we need to get efficient. Once you have an answer, check with the negative. All right, Rachel, when you have an answer to example B, hun, let me know. What is it?
It is 1.45.
Someone confirm, deny? Perfect. All right, do C. Once you have an answer again, compare. This is just kind of calculator practicing. And then the next time I see you, I'm going to teach you the other trick. All right, Mia, what do you get, hon, for C whenever you're ready? 0.33. Someone agree, disagree, confirm, agree? Rounding's fine? Okay. All right, let's go to where it says find the exact value, students. Exact means calc or no? Yes or no? No, no calc. All right, and here we go. Sine inverse of 1. First, let's talk about the answer that we are going to get. Is it going to be an angle, or is it going to be a ratio of two sides? See, so that's a little bit confusing, right? So let's talk about that then. Okay, just pay attention and then I'll wait for you guys to copy it down. Would you agree, whatever this is, I'm going to get an answer? Oh no, leave it blank. Is that okay? Whatever that answer is. Would you agree it's now an equation, but it equals a blank answer? I don't know. I'm going to fill that in later. Would you agree that if we are to go in and compose both sides by sine regular, okay, again, I'm going to go in and be like, okay, I'm going to compose, not multiply, okay, sine regular. What happened when you guys composed sine regular with sine inverse back in the day? Do they cancel? Yes or no? Yes. Okay, they do. So now we get 1 equals sine of this box, right, student? Okay, so now, is this box, should we fill in an angle or should we fill in the ratio? The angle. So students, trig functions, okay, when we are doing an inverse, your answer should be a ratio from the unit circle or from your right triangle, okay? So if you know it straight up, if you know the answer straight up, you can just fill it in. So what is the answer for sine inverse of 1? What should we write in? Pi over 2. Okay, so this is pi over 2 is the final answer. Now, remember, we talked about inverse just a minute ago. Sine inverse, students, can only be in 2 quads. Which 2 quads can sine inverse be in? 1 and 4. So let's talk about there. Is this answer in between 1 and 4? Yes, then that means we are right. Okay? Because technically, when you guys in regular, couldn't a trig function have multiple angles? In regular function, not an inverse, in regular. Couldn't it have multiple angles? So that's why we limit the inverse to only 2 quads. 1 quad will give me positive answer and 1 quad will give me negative answer. All right. Sine inverse again. Sine inverse is limited to what quadrant? 1 and 4. Is this right here a positive ratio? So that means this angle can only be coming from which quadrant? 1. So now think about the angle. What angle in quadrant 1 is going to give us a half? Give it to me in radians. Pi over 6. So again, if you don't know it, get yourself a box and go in and compose both sides by sine. Eventually, we will get super good at this, and sine and sine inverse will reduce. We know, students, your angle can only come from what quad again? Quad 1, because half is a positive. Right, guys? All right. Cosine inverse for letter D. I'm going to stop in a couple minutes, 2 minutes. Cosine inverse, students, is limited in what 2 quads? 1 and 2. So all answers, students, must come from 1 and 2. Okay. Okay. I don't know the answer. So if you can feel it, you can feel it straight up. If you need to go backwards and be like, let me think about it. I can compose both sides by cosine and then cosine. So 0 equals cosine of this answer. What should we write down? What is the box? What is it? 5/2. Ray just said. Agree or disagree? Yeah. So that's how we think of it. Right? Cosine of pi/2 is 0. Right, guys? So how important is the unit circle? Super. Because you can't do this without knowing the unit circle super fast. Last one, and we'll call it a day. Tangent inverse, students, are limited to only 2 quads. What are the 2 quads? 1, perfect, and 4, beautiful. Positive rod 3/2, students. So your answer must come from which quad? 1. Answer can only come from quad 1. Okay? And again, this is where it's super important for us to know the unit circle, and including tangent. You have to know it super fast. All right, so here we go. Ooh, what angle in quad 1 will give us tangent of rod 3/3? Pi/3. Yes or no? I want you to flip to your pi/3 and check really quickly. Pi/3. Is it sine divided by cosine? Dean? Dean said 5/6. Which one? It's 5/6. Chloe, do you agree?
Yeah.
Okay. All right, I'm going to stop right here for today.